Okay, guys, now we're going to talk about acids and bases. And they're important because when you go on to other sciences like earth and environmental, you need to know a lot about acids and bases. And today we're going to learn about one acid-base model. We're going to learn specific properties of acids, bases, and then we're going to be able to classify acids and bases as either strong or weak. So the first thing we're going to do is you may want to pause this video once I'm finished talking, and you need to copy this Venn diagram into your notes to know the different properties of acids and bases. Okay, obviously the pink circle is acids and the blue circle is bases. So that's usually the colors we use to represent them. Okay, you can see that we're going to talk about pH scale, and a lot of you are probably already familiar with that. But acids have a pH of less than 7. They have what's called a pOH, which is a measure of OH greater than 7. They have a high concentration of hydrogen ion and a low concentration of hydroxide ion, which is OH. They have a sour taste. Don't taste them. They turn litmus paper red, which you do need to know. They react with bases to neutralize. Remember our double replacement reactions from chemical reactions unit. And they react with metals to form hydrogen gas. Okay, now bases have a pH greater than 7, a pOH less than 7, a bitter taste, a very low concentration of hydrogen ion, and a very high concentration of hydroxide. They have a slippery feeling. They turn litmus paper blue, and they also react with acids to neutralize, which means they make a salt, an ionic compound with water, and they do not react with metals. Now, one thing they have in common, if you can see in the middle of the Venn diagram, they are all electrolytes. An electrolyte has the word electrum in it, just means it can conduct electricity. Electricity can run through an acid and a base. Okay, so if you need to pause this to write these properties down, it is something you need to know. Okay, so there are many theories. Actually, there's 3 theories that have been taught about what an acid and a base is. Now, we are only going to learn one here, okay? Honors and AP, they end up learning a second theory, and there is a third theory. Okay, but let's just focus on the one you need to know, which is called Arrhenius. Arrhenius is this handsome man down there, and he basically came up with this definition of what an acid is and what a base is. Okay, and he's saying that an acid, when put in water, produces H3O plus or H plus. Okay, and I'll show you what that means. A base will produce OH. Okay, so I'm going to draw a little simpler picture to make you understand what's going on here. Okay, and then I'll come back to this page. So in a nutshell, what he's saying is if you had a beaker of water, okay, draw a beaker, okay, and you have it with water in it, okay, water, and you threw an acid in it. Okay, so remember what a formula of an acid is. Okay, an acid has an H always at the front and followed by a nonmetal, right, or a polyatomic. And let's just pretend we're going to use hydrochloric acid, one that you should be familiar with. If you put this in here, what it's going to make is H plus ions. Okay, obviously there'll be Cl ions in there too. What really happens, and the reason why they say H3O plus, is this H plus reacts, if I drew a water molecule, this H plus actually attaches on here. Okay, and it actually makes H3O plus. Okay, so but for our purposes, we're going to say H plus equals H3O plus. Okay, And H3O plus is called hydronium, okay, the hydronium ion. Okay, so again, for our purposes, H plus will equal H3O plus. Okay, so his definition of an acid, I don't want to confuse you guys, I just want to give you that little extra info. You take an acid, put it in water, it's going to make H plus ions. Okay, so the definition says you need water as the solvent, and it's going to make H plus. That's the definition. Now a base, so that's an acid, Arrhenius acid. A base always has OH in it. Okay, so if you have another beaker of water, once again you have water, so you always have to have water. And if you threw a base in, and a base is going to have OH, like I said, so it could be sodium hydroxide, lithium hydroxide, barium hydroxide, anything with hydroxide at the end. And if you threw that into the water, it's going to make OH ions. Okay, and so that's the definition of an Arrhenius base. Okay, so this is what this means. Okay, now let's briefly talk about the pH scale. You should be pretty familiar with it from other classes, science classes you've had, but just to review again, it's a scale measuring basically the concentration of H, the concentration or molarity of H plus. Okay, and we're going to go into how to calculate pH, but the lower the pH, so remember it's a scale that goes from 1 to 14, between 1 and lower than 7, it's acidic. Between 7 and 14, it's considered basic. Okay, and in our next video, we are going to calculate pH. Okay, so let's briefly talk about strength of acids and bases. Okay, you don't have to know too much about this, okay, but there are several ways to memorize the strengths of acids and bases. The stronger the acid, that means it's going to be the lower pH, right, closer to 1, and the weaker the acid, the closer to 7 it would be. It is also a measure of how much of the acid is breaking apart into H plus. And as a base, it's a measure of how much of the base is breaking into OH. Okay. So just some strong acids is as far as hydrohalic, that just means halogens. Hydroiodic acid is strong, hydrobromic is strong, and hydrochloric is strong. A very weak hydrohalic that's common to know is hydrofluoric. Okay. Now we're going to skip the sans HO. Oxoacids are really called like the polyatomic acid. Okay. And you can measure them by looking at the oxygen-hydrogen ratio. Okay, so if I gave you H2SO4, if you took the difference between oxygen and hydrogen, it would be a difference of 2. And if it is greater than or equal to 2, that's considered a strong acid. So if you look at oxygen, there's 4 oxygens minus 2 hydrogens. That's a difference of 2. That makes it a strong acid. Something like nitric acid, where the oxygen's 3 and the hydrogen's 1. 3 minus 1 is 2. It's greater than or equal to 2, considered a strong acid. Okay, weaker would be less than 2. Something like sulfurous acid, if you look at that, the difference is 3 minus 2 is 1, which is less than 2. So that's an example of how to figure out whether it's a weak or strong acid if it has a polyatomic. As far as bases, if the base has an OH. Okay, we're just going to worry about the OHs right now. And if the metal that it's paired with is a group 1A or 2A metal, it is considered a strong base. So like potassium hydroxide would be a strong base. Barium hydroxide would be a strong base. Things with group 1 or group 2 metals. Okay. Now, although this is not considered an Arrhenius base, ammonia or NH3 is considered a weak base, a very common weak base. And then, of course, all other metals with hydroxide are weak bases. So iron is in the transition metal group, and it's not in group 1 or group 2. It's considered weak base. Okay, so that's just a brief understanding strengths of acids and bases. And again, just so you know that a strong acid and a strong base is measuring how much of those ions are breaking apart into the water. Okay, the weaker ones, not all of them break apart. Okay, our last topic, something that's important to understand, is something called an indicator. Okay, and the definition of an indicator, it's basically a chemical that's used to determine a substance's pH. Okay, so indicators will change to different colors depending on the measure, depending on whether they're added to an acid, a base, or a neutral substance. So for example, this is some different types of indicators, and it shows the colors they will have depending on what the pH is. And that's how you could tell what the pH range is based on the color it is. So you can see that for this universal indicator at the top, at a pH of 0, it would be red when added to something. It would be purple if it was 14. It would be green if it was neutral. Now, one that you should know, very common one, and I put it in your notes, is phenolphthalein. Phenolphthalein is important to understand that it has a clear color for anything that is acidic, going from a pH of 0 to 7. Once it turns basic, it'll turn pink. So that's an important one to write down and know. The rest of them you do not have to memorize. You do need to know litmus paper, as we talked about with the Venn diagram, and you have to know phenolphthalein. And that's going to be the end of this video, just kind of giving you a brief introduction to acids, bases, and their properties. Okay, the next video will be about pH calculations. Thanks, guys.